We have a good idea where rainfall comes from. But where does all that water go? A few hundred years ago, Kentucky's landscape was dominated by lush forests and expansive grasslands. When rain fell upon this untouched landscape, soil and plants acted like a sponge by soaking up much of the water before it could flow overland to the nearest stream. When the first settlers arrived in Kentucky, they began cutting down forested areas to build forts and homesteads. This necessary consequence of progress continues to this day, as development converts open fields and forests to roadways, rooftops, parking lots, and sidewalks. These surfaces are impervious, which means they're not capable of soaking up water. As a result, a large portion of the rainwater that once soaked into the ground now accumulates on these surfaces and has nowhere to go but to run off of the site and into the local stream. It also washes off many of the pollutants that have accumulated on these impervious surfaces, such as litter, sediments, pesticides, fertilizers, and chemicals that leak from cars. In most towns, this polluted runoff flows directly to the nearest stream without proper treatment, thus causing environmental and health issues downstream. As the size of our cities has continued to increase, so has the realization that the massive volume of stormwater draining from our communities can lead to increased flooding, impaired water quality, and harmful impacts to aquatic ecosystems downstream. Through the years, we've found that few of our man-made technologies for reducing runoff and improving water quality are as effective as the natural ability of soil, plants, and microorganisms that have existed in Kentucky for millennia. Green infrastructure uses these natural systems to provide a more sustainable and practical approach to managing the quantity and quality of stormwater runoff. It's called green infrastructure because plants and soils are used to mimic the water-loving characteristics of natural landscapes. So as you can see, the runoff that's captured in catch basins downtown would flow directly to a stream like this. And this occurs in most cities in the United States. However, that water is never treated before it arrives here. It does not go to the wastewater treatment plant. It goes directly to the stream, laden with sediments and debris. And what we want to do is moving towards the green infrastructure approach, is try to capture these pollutants before they have an opportunity to arrive at the local stream. Two of the major concerns associated with stormwater are local flooding and pollution. When rainwater isn't allowed to soak into the ground, this causes a much larger quantity of water to flow directly off of the site, carrying the pollutants washed off of impervious surfaces. While green infrastructure is proving to be an effective means of reducing and treating much of the stormwater generated from urban surfaces, we may always need certain aspects of gray infrastructure to prevent flooding that may result from the most extreme storm events. Gray infrastructure is a term used to describe the conventional stormwater management systems of curbs, gutters, catch basins, and underground pipes that capture and convey stormwater in our communities and deliver it to the nearest stream. The primary purpose of gray infrastructure has been to remove stormwater from urbanized areas as quickly as possible, so that it doesn't lead to local flooding. However, they don't do a whole lot to improve the quality of stormwater runoff. Consider, for instance, the water body where your drinking water comes from. Now imagine the pollution and debris draining from the cities located upstream of your water resource. The pollutants and debris that arrive in the source of your drinking water must be removed using expensive treatment technologies before it's safe for public consumption. Pollutants can originate from almost any type of urban surface that comes into contact with stormwater. Shingled residential rooftops and flat commercial building roofs can leach metals, hydrocarbons, and sediments. Litter and debris that collects on sidewalks and city streets can float away to the local stream. Impervious surfaces, such as roads and parking lots, collect hazardous fluids that leak from cars and trucks. Green infrastructure is designed to treat stormwater carrying these pollutants by capturing the runoff resulting from the most frequent rainfall events. Approximately 90% of the stormwater runoff in an average year in Kentucky is the result of storms that accumulate less than 1.5 inches of rainfall. And this is the quantity of stormwater runoff that green infrastructure is usually designed to capture. Capturing this stormwater not only reduces the large quantity of stormwater runoff throughout the year, it also captures the highest concentration of pollution resulting from the first flush. The first flush is the first portion of runoff resulting from a rain event. Debris, litter, and pollutants leaking from cars build up on impervious surfaces during the dry periods between rain events. When the next rain event occurs, these pollutants wash off in higher concentrations. By designing green infrastructure to capture the first flush, we're capturing and treating the most polluted portion of stormwater runoff. Once the first flush is captured, any additional stormwater runoff is allowed to safely overflow into the gray infrastructure system, thus reducing the potential for flooding. And since most of the rain events don't exceed 1.5 inches, green infrastructure can capture a majority of the annual runoff. The nature-mimicking benefits of green infrastructure can be used in combination with gray infrastructure to effectively reduce the impacts associated with stormwater. In doing so, we'll help to improve the quality of our drinking water and increase the sustainability of the vital resources that we depend on. By providing areas where stormwater can soak into the underlying soil, this portion of the stormwater is eliminated from the potential runoff that might otherwise flow untreated to the nearest stream.
We just had a lot of flooding where I live just recently, so I was hoping that I might learn something to help to address some of the flooding issues that we have.
This was an opportunity for me to come and just take back some great ideas that Louisville is obviously implementing, that maybe some cities across Kentucky, on a smaller scale obviously, can implement where they are.
I came out here because I'm with the Division of Water and I want to inform people on ways they can stop stormwater from getting into these drainage systems and everything, maybe get into the drinking water. And it's a problem we need to tackle.
We're trying to incorporate some green infrastructure into our city and into any new development that comes on into town. So we're trying to learn about it ourselves so that we can go home and educate the folks at home.
There are 3 natural processes that green infrastructure uses to treat and reduce stormwater runoff. These processes include infiltration, bioremediation, and evapotranspiration. Infiltration occurs when water is allowed to soak into the porous spaces within the soil structure. The stormwater that is absorbed by soil can then be used by the plants and microorganisms growing in the soil, evaporate back to the atmosphere, or continue to filter down through the soil into the groundwater table. The term bioremediation refers to the ability of microorganisms and plants to use the chemical compounds in stormwater pollutants as a food source. When plants and microorganisms use these pollutants as food, they break them down into chemical compounds that are less harmful to human health and the environment. Fortunately, common soils are loaded with microorganisms capable of breaking down the common pollutants found in stormwater. Employing microorganisms for reducing pollution is nothing new. Most wastewater treatment plants cater to particular microorganisms that thrive on consuming our raw sewage. These helpful microorganisms are responsible for making raw sewage safe enough to release to local streams and rivers. And the same helpful microorganisms can be found in green infrastructure. The process of transpiration and evaporation used by plants is referred to as evapotranspiration. Plants have a tremendous capacity for pumping water from the soil and returning it to the atmosphere through evapotranspiration. For example, research has shown that an acre of corn is capable of returning 3,000 to 4,000 gallons of water to the atmosphere in a single day. Green infrastructure may not be able to eliminate all of the stormwater runoff originating from our towns, but it can dramatically reduce a large portion of the runoff during the course of a year and treat many of the pollutants carried with it. Green infrastructure comes in a wide variety of forms that are only limited by the creativity of the designer. But some of the most common forms of green infrastructure include green roofs, rain gardens, vegetated swales, and permeable pavements. Many of the techniques we refer to as green infrastructure today have been used in communities for hundreds of years, if not thousands of years. Take, for instance, the green roof. Using sod to cover rooftops has been used for centuries in parts of Europe to keep the building interior dry from the rain. However, vegetated roofs have also proven to be useful for insulating the buildings during cold winters and hot summers. Modern green roofs have also been shown to last longer compared to conventional roofing materials such as shingles and chemical sealants on flat roofs. One example of a green roof can be found on the Service One Credit Union building in Bowling Green, Kentucky. Although this green infrastructure BMP is typically installed on flat roofs, this project provides an example of how green roofs can be installed on sloped surfaces. When designing green roofs, it is critical to choose plants accustomed to the temperature extremes that roofs are typically exposed to. In Kentucky, there are several species of plants that grow on rocky outcroppings that experience extreme heat and dry conditions, similar to rooftops. Using plants accustomed to these conditions will help ensure their survival and improve the performance of the green roof. The roof is most attractive when the plants are trimmed to a consistent height. To maintain the height of the plants, they place goats on the roof to nibble off the excess stems of the plants. And the goats are also comfortable accessing the steepest portions of the roof that would be difficult for humans.
CEO of the company, Nana Lampton, always wants to do her part in helping the world out. Nana is a very special person when it comes to that, and that's how this roof came about. She pollinated the city. There's people up here that are looking at it, they want it, they're looking at ways to do it to their building. That's the reason, it's growing the way it is. There's like 9 to 10 different sedums on this roof. And if you look at it, it's like a little forest. I mean, they all look different, but they're all a species of sedum. The roof is also capable of holding nearly 70% of a 6-inch rain. If we get one within an hour, it would nearly hold. If the roof is almost dry, it would nearly hold 70% of that rain. It has a natural filtering process it goes through because it's filtering through crushed slate and the material that the roof has on it. And also, of course, warming. I mean, this roof, it's a hot day today, no doubt. But you can stand up here on this roof and it feels like you're standing down on the ground. So you don't have the reflective heat that all buildings cause in cities. It protects the membrane of the roof. There's no UV rays that can get to the roof. So therefore, you take a 20-year roof, which is a standard life of a flat roof, and you extend it at 40 to 50 years, possibly, even longer. There's no cons in a green roof. It's all pros. Here than you are down on Main Street.
It feels better here than it did when we were
Down on the street.
This is our green roof at the Muhammad Ali Center. Some of the challenges that we had on this project, obviously accessibility. All the roofs that we do, you do have to have cranes on. That's not a typical landscape company. It's using a lot of cranes. This is a specified system. It's not your typical landscape. So there is a process that is involved, and you have to know it pretty well to have great success with them. This specific green roof is an added benefit to this building for more event space. It does have stormwater retention capabilities, decreases your solar reflectivity. There's a lot of great added benefits.